Hello and welcome to another Unity tutorial. My name is Corey and today I'm going to be showing you how to use the ChunkMaster framework. So here I got my new project open, ChunkMaster example, and let's go ahead and import our package. So you can find it on the Unity store, download the package and open it up. And I'll show you exactly what you need to use in order to create your own Minecraft or The Sims or anything like that. So, depending on which version you have, this is a very early version, so it might look different from this. But the bottom line is these scripts here inside the ChunkMaster folder, this is where all the important stuff is. And if you just want to have this along with the Visual Studio project that comes with it, you can just check this box and import it. But for the sake of this tutorial, I'm going to show you what comes with the package when you download it. So here we have the assets, the demo, and the documentation itself. Let's go ahead and import it and see what we have. So this is a small package. I think it's about a couple megabytes, not very large. That's because there's no images, well, maybe one or two, but it's a very small package. So along with the package, you get a demo scene. So here I have my little testing script. I probably shouldn't have that there, but I do have a demo scene. So let's go ahead and open up the demo scene, and here it is. So the demo scene, what do you get? So here we have a couple controls: left click to add block, right click to delete block, and so on and so forth. Movements left and right, up and down arrows. Perfect. So this rotates the camera. What do you see here? What does all this mean? Well, we got a couple buttons on the top right. We have delete world and save world. Unfortunately, there are no blocks inside, so we're going to need to place them. And from our tutorial, we know that left clicking will add some blocks. Now this does look kind of familiar, right? It looks like Minecraft. Well, although you can use this package to remake Minecraft, you'd need to use your imagination and think, what else can I use this package for? Not only can you create an infinite world, but you could probably make a 2D infinite world. So instead of placing blocks, you'll place buildings, kind of like SimCity. So let's say this is some kind of skyscraper here. And let's say you were deciding to make a game like The Sims and you want to have like a house editor and you wanted to make a wall. So here this would be the wall, I don't know, and here would be a kitchen. And you'd want to save. If you want to delete something, you just right click on it. If you want to save your world or your map, you can go ahead and press save. Now you can see at the bottom here at the console, world save at this current location. So depending on what you name your world, you should be able to save the folder given. The folder name should be the world name. So here it is. World has a couple files here that's automatically generated depending on the coordinates of your blocks here. So this is not a voxel script package. This is a abstract package for creating an infinite world. Infinite amount of space. Basically the limit is the space on your computer. That's basically all it is. So if you wanted to delete your world, well, there's the button. Click delete. There we have it. So now the folder should be gone. There it is. It's gone. So how do you create something like this? It's a pretty good demo. It also has a load feature, so you can definitely load your blocks. And as you can see, this template also has the blocks disappearing the further you go, which is very interesting. So how does the load feature work? Well, let's go ahead and stop this, hoping that I press saved. If I press play, unfortunately, since I did not save it, it will not load in. But you'd say I made a nice little circle here. Quick little circle. and I press save. There it is in the console, save, and I press close, and I run again a second time. And now we should see that everything's loaded back in. So the loading is very, very simple. There's practically no programming involved. So without further ado, let's get started and let's learn how to script this. So let's open up a new scene. Let's pretend like we just created a new project and we have imported our project, our assets. We're going to create a new script called ChunkMaster example. Press OK. We're going to create a new object, and we are going to assign that component to the object. And we're going to rename the object to world. Why not? Okay, so like I always say, here's the meat of the project. How does it all work? How can you create an infinite world? I'm going to show you. It's very easy. It's a very simple, and as I described it in the asset store, any beginner developer will have no issues with this whatsoever. So let's get to it. I would like to first import the ChunkMaster framework. So let's go ChunkMaster. Since we are using the Unity engine, we will use Unity, and we want to use the framework itself. So that's all you need to write for using. Next, we're going to create a public static data member, and it's going to be called my world. But first, we need to define what kind of data type is it. The package comes with a Unity world data type. So this is our data type, and our variable name will be my world. Excellent. Let's go to the start method and let's instantiate it. We're going to create a new Unity world object, and inside here we're going to need to specify a few things. Although 3 of these 4 parameters are optional, the first one is mandatory. What is our world going to be attached to in a game object sense? What is the world object going to be? Is it going to be part of an empty? Is it going to be part of a vehicle? Maybe you have a vehicle that has many blocks attached to it. In our case, we'll just use this empty as the world. So we'll just type transform as the object, the current parent. And we can also rename the world if we would like to specify a name of our world. We can do that as well. The chunk size and the sector size, we don't need to touch this. We could leave it at the default parameters. Let's just leave it like this. You don't need to worry about these values. All we need to do is create a world and assign a parent to it. Excellent. So, congratulations. You've just created an infinite world using 3 lines of code. But how could this be? How does it work? How can we place a block in the world? Yes, we have an infinite world, but how can we place a block? Well, it's actually quite simple. All you need to do is take your world object, and using the dot operator, it will show you many, many, many methods that you can use to edit your world. Clear block, clear chunk, clear sector, clear sectors, get block, get chunk, get sector, and so on and so forth. Let's start with the basics. Let's set a block on the floor. So let's use the method setBlock, and it requires a point in world space and the content that you would like to store that block with. So first, let's create a point in space. Vector3 point will equal to new vector3, and this could be any number you like. You could use a float, you can use an integer. It doesn't matter, because the world script actually snaps your points to grid. So if you use a decimal, let's say 2.35f, and let's go into negatives here because I know whenever you round something, it goes up. So if you go into negatives, anyway, don't worry about that. Don't worry about the snapping using negative numbers. All you need to know is that, yes, thank the Lord that it works with snapping in the negatives. Let's go minus 6.89f, and let's use a crazy number. Let's go at 2,468. Perfect. So there's our point in space, and let's assign it to the first actual parameter. The second parameter requires an object type. This means that you could use any primitive type that you'd like. You could put a float, you could put a double, you could put an integer, you could put a string, right? If you wanted to place something on the ground, let's say grass, you want it to set at this point in space. I want this block to be grass, so you will type grass. Maybe you want to use a reference object, right? Maybe you want to use the world itself. You can put the world in there, although you'd have to make sure that your classes and your reference objects are serializable. And if you're a beginner programmer, all I'm going to tell you is just stick with the primitive data types such as integers and strings. Don't worry about references. So for the sake of this project, we're going to use ID numbers. If we look at those big projects such as Minecraft, they use ID numbers to represent their blocks. So let's say grass will be 0, dirt will be ID number 1, an anvil will be ID number 257. So this means that however they designed Minecraft, they decided to create an array of transforms, and we'll call these blocks, and they're calling out each block given an index. So if this doesn't make a lot of sense, don't worry about it. We will get to it later on in this video. All I'm doing is I'm creating a transform array of blocks, and we will spawn them later. So there you go. We've essentially set a block in space, and let's see how it looks inside the Unity engine. I want to make sure that I save my project so I can have the updates in my scene here. There we have it. We have our array of blocks which has nothing inside. Don't worry about it, we'll get to it soon. So when we press play, the only thing that you'll notice here is that our world object now has a little arrow on it. If we click on the arrow, we'll see that it's created an empty with a certain coordinate. And if we click on that arrow again, we'll see another coordinate, and inside that one is our final coordinate. So what do these mean? What does this hierarchy mean? The one at the top is your world that we've set using the constructor Unity world. Our transform is the current object. The one below that is a sector, which is a gigantic cube filled with other cubes. It's actually filled with chunks, and that's what these are. These chunks are set inside the sectors, and the blocks are set inside chunks. So the world is essentially split up into sectors, which are split up into chunks, which are split up into individual blocks. And you can edit this as many times as you want. If I wanted to create another block here, I can set another block. Let's say set block, and we'll go vector 3, 0. Let's place the block at 0, 0, 0. Why not? So there we have it. Now we have two sectors, one at this location, one at that location, and each one of those has a block somewhere. So what's neat about having everything split up into multiple objects is that if you wanted to cull out some chunks or some sectors or save sectors or edit chunks or edit sectors, You can do so using a looping system through each chunk, which will be a lot lighter on the CPU than if you were to, say, edit all the blocks in the entire world. It'd be nice to just edit each portion individually. And that's what this package is all about. It's about splitting everything up into manageable sizes. Excellent. So we have our setting methods. Let's say I was running around in Minecraft and I wanted to examine a block. Maybe I want to pick color a block, or I wanted to mine a block. First, I would have to check to see if the block actually exists, right? So here, if you want to find out if the block exists, we can go my world dot is occupied. And it requires a point in space. So if I use the same point as before and I decided to print out this value, technically we should see a true. Yes, point is occupied. Let's save this, go back in here, and let's see what happens. Okay, so if we see in the console window, we should see that yes, indeed, the point is occupied. True, perfect. There's a block at this coordinate. Although we don't see it here, don't worry about it. We'll get there. We'll put a block in space. It's gonna happen. So now that we know that the block actually exists, we can remove it. My world dot clear block using a point in space. So if we wanted to test this out, we can go print after the fact, and we should see a false statement, a true, point is occupied, clear the block, and then a false. So we've essentially just mined the block. So now what we should see is point is occupied true, cleared, and then false. There we have it. Point is occupied true, and then it's false. Excellent. So now that we've set a block, we've checked to see if it was occupied, we've cleared it, and we checked to see if it was occupied again, we've essentially just mined a block. Perfect. So, how do we save a block? Or how do we get a block? Before I show you how to save, I'll show you how to get a block. If you want to get a block's details, let's say you're mining the block and you want to see if it's diamond, if it's coal, if it's dirt. So here you would use a method called getBlock. Inside getBlock, you will have one formal parameter of a vector 3 point in space, and it will return a Unity block. So here you can go type Unity block, and we'll create a variable called block. And if we printed our block, we should get some details about it. But see here, we're clearing the block, so we're going to need to remove this. And in theory, if we print the block, we should see a value of 0, along with some other details since we're printing the reference object. So let's go ahead and press play and see what happens. There we have it. So the content is indeed 0, and along with it comes the world position. Perfect. Oh, it's great to have this as a string, but what if we wanted to get the complete content by itself? Well, each block has a method called getContent. So over here, we can simply print the actual ID number. There we have it, 0. ID number 0. And if we wanted to save it now, we want to save our world, we've done our edits, we would like to save it. Saving is just as easy as doing the following. World.save world. I have a sector saving method here because sometimes you have been editing your millions of blocks and you wouldn't like to save the whole world at once. Maybe you want to save each sector individually. So here you can save each sector one by one if you like. Or you could just go save world. It will iterate through all the sectors and save them. Inside here you can use a path URL, and you could leave it blank and leave it like this, or you can set the directory that you like. By default, I believe the default is application data path. Yes. So this means that if I were to save the world, it will save it in the current directory in here. Before I continue, I just want to delete my world over here. Press play. There we have it. I've done my edits. I've added my blocks. And if we check and explore, we will see my world has been saved. Excellent. How do we load a world now? Loading a world is just as easy. If I would like to load my world, I will use my world.load sector. And the sector will require a point in space. You wouldn't want to load the whole world. You'll only load the parts that you need. So here, I will load the current point that I saved earlier. I will load that point, and then I would like to display the block details. I want to see that ID number 0 that we've assigned to previously. So here I will go print block.getContent, save. I've commented out these other lines here. Now, let's see if this worked. By theory, we should see a 0 pop up in our console. Let's have a look. There we have it, 0. Excellent. So, we've saved the world, we've loaded a world, we've set a block, we've retrieved the block, we've cleared the block. Those are all the basics for the world editing. How do we assign a 3D object to this block? Yes, it's great that we get the block, but how do we show it on screen? Well, we can do it using the following method. Public void spawn block with a formal parameter of a Unity block. We will use this object and this object only to spawn our block. Spawns block as my comment, although it's pretty obvious given the method name. Excellent. So we do have our transform blocks up here, and we have all our details given to us inside this block. So the first thing we're going to want to do is get the ID that is stored inside this block. And the ID will be relative to these blocks transform array. So I will use blocks, and I will call it, give it an index. So here I will create a variable called I, and I will be equal to block.getContent. And because the object is, well, it's just what it is, it's an object, we need to cast it as our initial input, which was an integer. So let's cast it as an int, because that is what we assigned it in the first place. And inside here, we will retrieve the transform. We don't need the update method. Next, we'll create a spawn prefab method, void.spawn prefab. And this method will require two formal parameters. One of them is the transform itself, named the prefab, and the second one will be the point in space, in 3D space. Next, I would like to return it as well, so let's make it return a transform. The object will be created using the following method: instantiate prefab, and now we can manipulate it given the temporary object. We can set the parent to the current object, and we can set the position given the point in space. Finally, we will return the temporary object. So there's our spawn prefab method. Very easy, very simple. It should be point spawns prefab as my comment here. Perfect. Now we can take this method and plug it in. Now, we need a point in space. How do we retrieve the position of this block? You can do it using the following. Vector3 point will equal to block dot world position. Just as easy as that. Perfect. Now that we have our spawn block method, we can use this to load in our block. There we have it. So let's go back to Unity and assign our block to it, right? Because we do have an array of blocks over here, but we have nothing inside. So let's set the size to 1. And since we already have a block prefab inside our ChunkMaster, we can just drag and drop our blue block right into our array. Now when we press play, we should see that our block has been spawned at the correct location that we've determined. Now, one thing I should point out is that our block should be at the correct hierarchy stage. Right now, it's out in space. We should set it to be a child of the current point. So we're going to need to do a little bit of editing here. Inside spawn prefab, we can add a third formal parameter called parent. And instead of setting the parent to the current transform, we could set the parent to the parent object itself. And now back up here, since we have a new parameter to add, we will use the block.gameObject. And since we can only set a parent via the transform, we will need to call the transform data property. And there we have it. Now our block has a nice little house, which is a child of the block, assigned to this chunk, assigned to this sector, assigned to this world. Perfect. So now we've spawned a block in space. The next thing you're wondering is, gee, that's pretty great that you could spawn one block. But what about spawning multiple blocks? What if we wanted to spawn the entire sector, or spawn the entire chunk, or spawn the whole world at once? Well, I could show you in a separate video, or we can just go ahead and open up one of my world scripts here, world controller. Inside the world controller script, you have everything you need to edit the world. Inside here, we have spawn block, spawn chunks, spawn sector, set block, get chunk, get sector, clear world, clear sector, clear chunk, clear block, save world, load sector, save sector, and delete world file. This is all included in the package, ready for you to create your infinite world.